All right, so let's go ahead and summarize 7.1. In the beginning, for Unit 7, we're starting with the introduction to equilibrium. So the main thing to kind of focus here is to understand what this concept of the equilibrium really is and how it relates to a general reaction. So what I want to do is I'm going to go ahead and put some stuff on the screen, kind of briefly summarize the key points, and then we'll move on. We'll do that for here for 7.1, then we'll do the rest. So we'll begin with the generic equation here. We've got a general equation that includes two separate compounds. And the compound AB will react with compound CD and it'll produce some products. And if you look at this carefully, you're going to notice that this is a double replacement reaction. So the main thing to know here is that there is a difference between the concentration of all of these items on the reactant side and on the product side, and you need to be able to look at these changes in concentration over time. So the best way to kind of do this is to kind of get a graph that kind of depicts the concentrations of both. And so that will essentially look like this. And so let me go ahead and get this done here at the bottom. So if I were to kind of get a graph here that kind of generically depicts here the concentration here on the X, and time at the bottom, and it's going to increase as we go to the right. All what we're saying here is if I were to color code things here, let's just go ahead and do a color coding here. Let's say that we get A and B being red, and I get CD, let's say blue, and then we'll do here green for AD and CB, yellow. All we're saying here is that over time, if we look at the beginning of the reaction at 0 here, at the very beginning, there is no product. You don't have any AD or CB generated because it hasn't, the reaction hasn't really progressed. But what's going to happen here is the immediate step, as we learned in Unit 4, you're going to get some of these compounds here breaking apart. So you're going to wind up getting, from an initial standpoint, there is going to be a lot of AB and a lot of CD at the very beginning. So we can generate graphically here, we're going to get a certain amount of AB and a certain amount of CD at the very beginning. This amount here for both of these constitute 100% of what is available. Over time, though, these are going to be consumed, and so that's a negative process because you're no longer going to get 100. So you're going to reduce it by a certain amount, X, and it's decreasing. So the change we see is going to be a change in a negative X. And so both of these here, I'll just use a generic color here. The color here will, well, actually, let's use red, is going to decrease over time. And the same thing will happen here for B. And eventually it's going to flatline. So when we look at these, we can take any given point here, and you can see that the change here goes from a certain amount, and obviously if this point here is 0, you can have a certain amount of tick marks, and just for reference here we'll say 1, 2, 3, 4, and these are molar concentrations. So at the beginning here, at this point, we went from a concentration of 4, and as the reaction continued, it reduced to a concentration of 3 just in this little period of time. Now all these changes are going to happen, but eventually the change that occurs is going to flatline. Same thing for the red one. Now, on the other side of things, we've got AD and we've got CB. Now, at the beginning of the reaction, these reactant or these products, there is none. So let's say we can mark it there with yellow, here and here. Those do not exist at all at the beginning, but as the reaction continues, what we end up seeing is we're going to see an increase in the number of product that is going to be produced. And so in this particular case, we're going to wind up seeing something like this, increasing over time, and it'll flatline itself. Same thing for the yellow one. Okay. And these are not drawn to scale, but you kind of get the general idea here. Eventually, if we do the same kind of change, and just for graphic point here, if I pick this point here, let me use a slightly different color. If I pick this point here, and I pick another point in time, let's pick that one there, you can do the same thing here. But now, we go from a concentration of 1 to just under 2 because the movement here is going upwards. And so that is a positive event that you're going to see. And I didn't do this on the previous one, but this event here, this is going to be a negative event because we're going in the downward direction. But you can see both of these products and reactants at the very end, the change that occurs is not going to be very much. And when it happens, we can designate this point at the very end here, whatever point that may be, as K. This is the point where equilibrium is going to be established. And in general, in 7.1, this is exactly what we're trying to do. We're just trying to figure out what is equilibrium within the context of a reaction. And so one thing that you got to make sure that you understand here is that the reactants over time are going to be consumed, and that's negative, and the products are going to be generated, that's a positive event. And it will continue until we get to equilibrium. And so in the next section, we're going to be looking at how you establish that with respect to equilibrium.